All right, guys, so what we're doing today is we are picking up where we left off yesterday with solving, well, not solving, but with adding and subtracting rational expressions. For us to be able to add or subtract two rational expressions, we have to get the denominators to be the same. And the first main step in getting the denominators to be the same is factoring the denominators as far as possible so we can see what we need to multiply both of them by to get them to be the same. So we look at the first denominator, 12x squared. It is a single expression, so we can't factor it any farther. Now there is a greatest common factor on top and bottom, because 8 and 12 do have a common factor of 4. And as long as that's not necessary for our least common denominator to make both of those be the same, we can simplify it out here. If we're not sure, especially with numbers, we can go on and leave it. Now, as we look at the other denominator, x squared plus x, the greatest common factor between x squared and x is x, giving us x times x plus 1. Questions on this so far? Now that we have both of them factored, we can find the least common denominator, the least common multiple for the bottoms of these fractions. Now we can start off with the sets of parentheses, our expressions. On the right fraction, on bottom, we have x plus 1 once. We don't have it any on the left side, so the least common denominator is going to have to contain x plus 1 at least once. It's going to have to show up in both denominators. We're going to have to make sure it is in both. We can go to our variables outside next. The one on the left has x squared, it has two x's. The one on the right just has x. So we will need x squared in both. Since one of them has two x's, the other one's going to need two of them as well. And the last thing we need is our numbers outside the parentheses. The one on the left has 12. The one on the right just has 1. So both of them will need to be 12. Questions on this here? So now that we have this least common denominator, we know what we need both of them to be. We can multiply on top and bottom each of these expressions by something to get them to be that least common denominator, to get them to be the same. Now we can start with the one on the left because it has the 12x squared already. So what is it missing? It's missing the x plus 1. So we're going to have to multiply x plus 1 on top and bottom to get the denominator to be 12x squared times x plus 1. Now we can multiply also on top. 8 times x is 8x. 8 times 1 is plus 8. Now we need to do the same thing to the right side. Now on the right-hand side, we already have the x plus 1. We already have an x, but we don't just need x, we need x squared. Since it's missing an x on bottom, we're going to multiply it x on top and bottom, bless you, to get that x squared. What else will we need to multiply it by? 12. Because it's missing the 12. So those aren't connected. There we go. Bless you. Now on top, really on top or bottom, either one. Just need something messing with that and just make it, there we go. So, x times 12x, we'd still have the 12. X times x is x squared. Still have the x plus 1. On top, we have 12x times x. And 12x times x is going to be 12x squared. Questions on how we got to this point here? Now, a normal question that comes up, or at least you might have, is why do we distribute the top and not the bottom? And the key reason for not doing that is whenever we add two fractions, once the denominators are the same, the bottom of the fraction just stays whatever that expression is. Because 3/4 plus 5/4, we just have 3 plus 5 over 4. We're not having to combine like terms. We're not having to do any kind of addition, subtraction with terms. It's just that expression. And if something's going to simplify on top and bottom, we need that denominator to be factored. We need it in factored form. Yes? Is 12x squared times x plus 1 factored? Well, yeah, it's already in factored form. So there's not a whole lot of reason to multiply the 12x squared by x and 12x squared by 1, because if something simplifies, we're going to have to factor it right back out. Do we kind of get that with the bottom? Now, the numerators we multiply because we're going to add. We have to combine them. We have to add them together. So if there are like terms, we're going to have that multiplied out so that we can combine them. So the only place where there is addition or subtraction combining like terms going on is on top, not on bottom. Now, really, just like before, we didn't necessarily need the parentheses for this one here. Because when we resolve the first set of parentheses with the 8x plus 8, it still stays positive 8x, positive 8, so it's just 8x plus 8. Same with the positive 12x squared, it's just plus 12x squared. Now, to make things nicer so you're not just running out of room, before we rewrite in standard form or as we do that, is there a greatest common factor between 8x, 8, and 12x squared? Yeah, 4. Because 8 and 8x has a common factor of 4. 12 also has that 4. We can't use 8 because 12 is not divisible by 8, but 4 is the next option. So I'm going to do two things at once. So we know we can divide 4 out of all three terms, yes? And the reason I'm saying two things at once is, well, I'm going to move this 12x squared at the same time. Because if we factor 4 out of 12, we get 3, yes? 3x squared. So instead of leaving it in the back, I'm going to go on and move it to the front, just so we rewrite it. I'm doing this because the alternative is we rewrite it as 12x squared plus 8x plus 8, and then factor it out. Now, if we factor the 4 out of 8x, 8 divided by 4 is 4, we get 4x, and lastly, we get 4. Questions on this here? Yes? 2, thank you. I completely spaced. Yep. That should be 2 and 2. Thank you. Yep. I was more focused on the first term than I was actually dividing those out. Questions on this here? Is there something in common on top and bottom? Because we're kind of at that yes and no, because sometimes we can do it, sometimes we can. It depends on the setup, the situation. If we have factors on top that are being multiplied, then we can. Because do we have two things being multiplied on top of this fraction? Well, yeah, we have the 4 times that entire expression, yes? And on bottom, there's one thing that the 4 is in common with is the 12. Is the 12 have a product on bottom? because we're multiplying the 12 with the x squared and that x plus 1. 4 over 12 is going to reduce to what? Reduces to 1/3 because they have a greatest common factor of 4. Because it reduces to 3. Yeah, no, you're right. Yeah. So since we have that common factor of 4, the 4 is being multiplied on the outside, it's going to reduce completely, leaving us with, should be a 3, 3x squared plus 2x plus 2 on top. We remove that 4 from the 12, it's going to become 3. We still have the x squared and the x plus 1. Questions on how we got to this here? We feel comfortable with all these steps so far. Will the 3x squared on top cancel with the 3x squared on bottom? Operations, let's look at operations to make sure. On bottom, the 3x squared is being multiplied with the x plus 1. So that means it can simplify. At least the bottom is eligible to be simplified out. On top is the 3x squared being multiplied with something else. We have what next to it? The plus. The 2x plus 2. Because it has addition between the 3x squared, 2x, and 2 on top, it's saying that whole expression is one term. It's stuck together. The 3x squared on bottom is being multiplied, so I could do simplifying with it. But since the 3x squared on top is being added to the 2x and 2, I can't just cross them out because of that. Does that make sense? Because if we had it as saying 3x times 2x plus 2, yes, we could simplify just like we did before. But because of that addition on top with the 2x and 2, it's stuck. This is most likely as simplified as it gets. The only way we can simplify further is if 3x squared plus 2x plus 2 factors. It does. I don't feel like it does. And instead of going through the full process of 2 sets of parentheses with 3 spaces, I'm just going to grab this tool. Square root of b squared minus 4ac. And for us here, the value of b is positive 2. 4. A is positive 3, and C is positive 2. Second square root, positive 2 squared minus 4 times 3 times 2. Domain error. So that tells me that the solutions are complex, which means it doesn't factor, because we can only factor quadratic equations that have rational solutions. As far as it goes. That is simplified. Questions on this here? Now we're going to find the difference. We want to find the difference between these two things. Now the way we find the difference and the way we find the sum is going to be the exact same, because the first thing we need to do is factor the denominators as far as possible to figure out what the least common denominator is. Now with the denominator on the left, we have 2x minus 2. Is there a greatest common factor between these two terms? Yes, it is 2. And if we factor the 2 out of 2x, we get x. We factor the 2 out of 2, we get 1. And it stays x minus 1, the minus stays, because we're not factoring out a sign. If we look at the other denominator, x squared minus 4x plus 3, there is no greatest common factor. So we'll have our 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is positive, so the signs are the same, and they're going to match the sign of the middle term. So we have negative and negative. Now our factors of x squared, first term, we only have one set, x and x. Now the factors of 3 are 1 and 3, yes? And I can check this here off to the side. X times negative 3 is negative 3x. Negative 1 times x is negative x. Telling me that because of this setup, the middle term is negative 4x. That is the middle term we wanted, so those are the correct factors, yes? Now I also talked about, especially when we simplify radicals or multiply, we look for things in common on top and bottom. That helps us find factors. I would do similar things here. Because x minus 1 showed up on the bottom of one of them, we hope it shows up on the bottom of the other. And the reason I say that is because if we're going to add or subtract, we have to make sure the denominators are the same. So I'm going to change this for a second. Let's say this was 2. That's fine. Doesn't make a big difference. But if to make the denominators be the same, this left-hand side is going to need an x minus 3 and it's minus 2. It's going to need both of them. I'm having to multiply by a quadratic. I'm adding terms, which is fine. And if that happens, that is what it is. But with this setup and how it factored, the one on the left already has the x minus 1 that the one on the right has. They are the same there, yes? What is the only thing the left one's missing that the right one has? X minus 3. It has the x minus 1. It's fine that it has a 2. But the only thing it doesn't have is that x minus 3. So I'm going to have to multiply on top and bottom by x minus 3. Can we see what we did there? We're just trying to make them be the same, that least common denominator. We're just not specifically writing it out. On the right, the left has the x minus 1. Now that we've multiplied or going to multiply, we'll have the x minus 3. So what's the only thing the right side doesn't have that the left side does? On the bottom, it's just missing the 2. Because if I multiply the right side by 2, it will have the 2, it will have the x minus 1, so it has everything that it has. So if we look just at the multiplication on bottom, on the right side we have 2 times our x minus 1 times our x minus 3. On the right side, we're going to multiply the 2 with the x minus 1 and x minus are the denominators the same? Yeah. We did the exact same thing as we did on the last two with writing with the least common denominator, finding what they're going to make, what we need to make them be equal. The only thing we didn't do was actually just write what it was. Does that make sense? This is how I do most of these here. I just figure out what's going to make them equal. I'm not going to specifically state what the least common denominator is, but that's what we do to find. Now we need to do the same thing on top. So we could rewrite this as x minus 3 times x plus 2. Or we know that they're going to have to be multiplied. So we're going to have to distribute this out. X times x is going to be x squared. X times positive 2 is positive 2x. Negative 3 times x is negative 3x. Negative 3 times positive 2 is going to be negative 6. We need to do the same thing on the other side. Now, even though there aren't parentheses around negative 2x minus 1, we might as well, there are. We just know that they are, we just don't write them. 2 times negative 2x is negative 4x. 2 times negative 1 is almost negative 2. Questions on this here? One last thing before we put them together, we will need to combine like terms. Goes on the left-hand side. negative 3x plus 2x, 2x plus, or 2x minus 3x will give us negative x. 2 minus 3 is negative 1. Questions on this here before we subtract? Denominators are the same, so we can subtract the numerators. Put them on the same parentheses and, or same fraction, not parentheses, same fraction, and we're going to subtract. Now, resolving the parentheses for our x squared minus x minus 6. The only number in front of it, not written, is 1, and it's positive. So the x squared is going to stay positive. Negative x, negative 6, the sign does not change for any of those terms. But our second set of parentheses has what in front of it? It has that negative, yes? Which means this negative has to be applied all the way through. So the negative 4x is going to become positive 4x. The negative 2 is going to become positive 2. A very common error is only applying that negative to the 4x, the negative 4x. Time and time again, I've seen it too many times. It happens all over the place. We'll rewrite this as x squared minus x minus 6 plus 4x minus 2. But it has to be applied to both. Now, this is the first one we've actually come across that we can combine like terms. Because x squared does not have any like terms, but our negative x plus 4x, negative 1 plus 4, is positive 3x. Negative 6 plus 2 is negative 4. Questions on this here? Now we can say this is finished as long as x squared plus 3x minus 4 does not factor. B is 3, A is 1, C is negative 4. So we go second square root. Yeah. 3 squared minus 4 times 1 times negative 4. Yep. And we get 5. No decimal, no domain error. That tells me it factors. Doesn't tell me what the factors are, it just tells me that, yes, this does factor. And we're hoping one of the factors is what? X minus 1 or x minus 3. There is no greatest common factor between x squared, 3x, and 4. So we can go straight to our two sets of parentheses. Since the third term is negative, the signs are opposite. Factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. Well, if something's going to simplify, we don't want it to be 2 and 2. So we're going to use 1 and 4. Which one do we want positive? Which one negative? All right, the positive 4, negative 1. Well, the reason I say it this way is because if something simplifies, what we have on bottom is x minus 1. So we'd want the 1 negative on top so that they match and cancel out. X times negative 1 is negative x. 4 times x is plus 4x. Negative 1 plus 4, negative x plus 4x gives us that positive 3x that we wanted. So since those are the right factors, we can say that x minus 1 over x minus 1 will cancel out, leaving us with x plus 4 over 2 times x minus 3. And that's it. Questions on this here? So subtraction, a real big difference from addition? Not really, outside of this step here, remembering to distribute that negative through. Questions on this here? 5x minus 1 over x squared minus 3x plus 2 minus negative 2x minus 1 over 2x minus 4. You want to factor the left denominator or the right first? X squared minus 3x plus 2. There is no greatest common factor amongst these three terms. So we'll have two sets of parentheses with three spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, since the 2 is positive, signs are the same and match the sign of the middle term, which is negative, so we have negative and negative. Factors of x squared, x and x. That's the only factors for x squared. And the only factors of 2 are, well, 1 and 2. And if we check this, x times negative 2 would be negative 2x. Negative 1 times x is negative x. Negative 2x minus x, negative 2 minus 1 is indeed negative 3. So that is the correct factors. On the other denominator, 2x minus 4, there's a greatest common factor of 2. And we factor it out, we get 2 times x minus 2. Now, just like with the first two, we can look at both denominators and list out what the least common multiple is, the least common denominator, and then figure out what we need to multiply both by to get them to be the same. Or the main way I do it is I look at one. We can look at the one on the right first. So it has 2 times x minus 2. What does the left side have that this side doesn't? X minus 1. So I know I'm going to have to multiply x minus 1 on top and bottom. Then we go the other direction. And we say, what does the right side have that the left side doesn't? 2. Exact same procedure. But we're not looking at both, listing it out, then doing the multiplication. We get to the same spot, but just a little less work. If we multiply the denominator, we're going to have 2 times x minus 1 times x minus 2. On top, we do need to multiply through that 2. 2 times our 5x. 2 times 5x is 10x. 2 times negative 1 is negative 2. Minus. On bottom, we do have 2 times x minus 2 times x minus 1. Now on top, we're going to have to distribute this out. Negative 2x times x is negative 2x squared. Negative 2x times negative 1, the negative and negative make a positive. So 2x times 1 is 2x. Then we're going to go negative 1 times x is, well, negative 1x. And lastly, negative 1 times negative 1 plus 1. Bless you. Now, before we actually subtract, it'll be helpful to do some simplifying, combining like terms on top and bottom. Because we do have negative 2x squared, but our 2x minus x, 2 minus 1, is just going to give us positive 1 plus 1. Now that we have the denominators the same, we have the numerators simplified, combined like terms, so we're not having additional not unnecessary, just a lot of extra terms. We're going to go on and subtract the numerators. Now, especially with this subtraction, it's going to be helpful to put the parentheses, because even though 10x minus 2 is still going to be 10x minus 2, the second expression, we're going to have to distribute that negative through, which is going to turn our negative 2x squared into positive 2x squared. It's going to turn our positive x into negative x and our positive 1 into negative 1. Combine like terms. 2x squared, the x squared, there's no other x squared term, so it's by itself. We put it in the front. 10x minus x plus 9x. Negative 2 minus 1 is negative 3. It feels like this could factor. Yes, 2 and 3 trying to get to 9, there's a chance it works. But I don't like the fact that the third term is negative. Because if the third term is negative, the signs are opposite. One's going to be positive, one's going to be negative. So we're not necessarily combining them together. So square root 9 squared minus 4 times 2 times negative 3 is square root of 105, 10.246. Again, we get this irrational decimal, so it does not factor. And since there's no greatest common factor between 2x squared, 9, and 3, there's nothing to factor out, so we can't simplify there. This is it. Questions on this here? Yeah. How do we feel with addition and subtraction? Because the big thing with addition and subtraction is just getting those denominators the same. Because once we get them the same, add or subtract the numerator, simplify where necessary. I'm going to rewrite this below it. But if we look at these two here, they're being subtracted. 4x is as simplified as it gets. 7 is as simplified as it gets. Now, for the most part, we don't want to just multiply the two numbers on bottom, especially if they're not in parentheses. So tell me this, or answer this. 4 and 7, is there a number in common with both? Is there a number divisible that is divisible into 7 and 4? We can divide 7 and 4 by? No, 7's prime. So, and the reason I'm saying that and mentioning that, the least common multiple is smaller than their product if there's a number or a factor in common with both, because then that's getting doubled or adding more than times than is needed. Here, if I multiply 4x by 7, 4 times 7 is 28x. 7 times 4 is 28. Actually, that is the first number that gets them to be the same. That is the least common multiple. On the left-hand side, I'm going to have to multiply the top by 7 as well. 7 times 3 is. And we would have to multiply the right-hand side by 4. Yes. But we're missing one term on the right. What are we missing? X. Because we have 4x. The right-hand side is technically missing the 4 and the x to get them to be the same. Because 7 times 4x, 7 times 4 is 28. And we have the x, 28x. On top, 1 times 4x is 4x. Since the denominators are the same, we can subtract the numerators. Oh, wait. 21 is going to stay 21. 4x is going to become negative, getting us this here. Yes? Is there a greatest common factor between 21 and 4? No. So there's nothing to factor out. There's nothing to simplify. 21 minus 4x over 28x is the final answer. Because again, it sometimes feels like we have to factor, we have to simplify. It doesn't have to. But we always want to check and make sure to see if it does, because if it does, we need to. If it doesn't, we leave it as is. Questions on this here? You can. Yeah, you can put the negative 4x in front and say negative 4x plus 21 over 28x. That's fine too. Let's look at one last one. Let's look at this one here. And we'll actually be done with 741. First thing we want to do is factor the denominators as far as possible. Now, it doesn't matter which one we start with. I'm going to start with the 12x minus 48. Because it looks like there might be a greatest common factor between 12 and 48. Because we know 2, 4 possibly. Because 48 is divisible by 4. Like that's 12. So we can actually factor not just 4, we can actually factor 12 out. Because 12 divided by 12 is 1, leaving us with x. And 48 divided by 12 is 4. Now the other denominator, x squared, x, and 12 do not have anything in common besides 1. Since the third term is negative, the signs are opposite, positive and negative. Factors of x squared are x and x. Now I'm going to list out the factors of 12. 1 and 12, 2 and 6, 3 and 4. I'm going to have to give myself room here in a second. But any of these could work. I'm leaning towards 3 and 4. Because if it is 3 and 4 and the 4 is negative, we already have something in common on both sides, which means that's one less factor I have to multiply both sides by. And if we check this, x times negative 4 would be negative 4x. 3 times x is plus 3x, telling us that we do have the negative x middle term that we wanted. That is definitely not what I wanted, and it's not going to give it to me. All right. There we go. Questions on how we got to this point? We'll start with the right side. It really doesn't matter. What does the left side have that the right side doesn't? The x plus 3. So by multiplying x plus 3 on top and bottom, we'll have the two sets of parentheses, x minus 4 and x plus 3. If we do the same thing on the left-hand side, what does the right-hand side have on bottom that the left side doesn't? It's missing the 12. And when we do this product, the left-hand side, 12 times x is 12x. On bottom, we'll have 12 times x plus 3 times x minus 4. Now on the right side, on bottom, we'll have 12 times x plus 3 times x minus 4. The order in which we do the parentheses, again, doesn't matter. On top, we'll want to multiply through by 5. 5 times x is 5x. 5 times 3 is going to be plus 50. Questions on how we got to this point here? $12x plus 5x plus 15. Now here, did we really need the parentheses? No. We can drop those and combine our like terms. 12x plus 5x is 17x plus 15 over 12 times x plus 3 times x minus 4. And that's actually as simplified as it gets. Part of the indicators or the reason I can say that is if we look at the top, do we have an x squared term? No. So our normal factoring with two sets of parentheses is not going to work. So the only other thing that we could do to factor it is greatest common factor. 17's prime. Or if we look at 15, besides 1, 3, 5, and 15 are divisible into 15. 17 is not divisible by 3. It definitely is not divisible by 5. And I think 15 is way too close for that one to work. So all of our options are out. Questions on this here? All right. That is it with 731. Now, several of the ones on there is just list or least common multiple. That's all you have to do on some of those. So make sure, especially read the instructions with what it's asking, because 4 through 6, find the sum or difference.
Just a reminder that there will be a Bible study today at 11. Thank you.
So those denominators are already the same. 8 is also that way. 12 through 14, find the least common multiple of the expression. That's all you're looking for. 20 through 23 is what we did today, and so is 26.